So this is part 1 of the final exam review video. When we solve linear inequalities, we want to get the variable by itself on the left, and that way the inequality will point in the direction that we're going to shade. What's my first step going to be here? Distribute the 4. So when I distribute the 4, I get 4x minus 12 minus 3x is greater than or equal to negative 7. Then I can combine like terms, and I can also add 12 to both sides. Remember, what you do to one side of an equation you have to do to the other. And when I do that, 4x minus 3x is x is greater than or equal to, because the 12s are going to cancel out, and 12 minus 7 is 5. If I were to graph this solution on a number line, I would have a 5 right here, and I would use a closed circle and shade everything to the right. The instructions here ask you to write your answer using interval notation. So using interval notation, would I start with a parenthesis or a bracket, and then 5, comma, infinity, parentheses. Positive and negative infinities always get parentheses, so this would be the solution to problem number 1. On number 2, we have a compound inequality, and when you have a compound inequality where you have 3 parts, you have to do the same thing to all 3 parts, and the goal is to get the variable by itself in the middle. So my goal is to get y by itself in the middle, so the first thing I want to do is subtract off 7, but I've got to do it from all 3 parts of this inequality. And when I do that, I get negative 9 is less than negative 2y is less than 5. How do I get the y by itself now? Divide all 3 parts by negative 2, but when I divide by a negative, what do I have to remember to do? Flip the inequality. So when I do that, negative 9 divided by negative 2 is 9/2 is greater than y is greater than negative 5/2. This is not in standard form until you have the smaller number on the left, the larger number on the right, and the inequalities pointing towards the smaller number. Well, my inequalities are pointing towards the smaller number, so I can just flip this and write negative 5/2 is less than y is less than 9/2. I've swapped the numbers on the ends here, but notice the relationship between the variable and the inequalities is the same. This is saying y is bigger than negative 5/2. This is saying the same thing. Y is bigger than negative 5/2. Do y'all see that? If I were to graph the solution set on a number line, I would need a negative 5/2 and a 9/2. And I would shade everything in between, and I would have open circles here because this is a strict inequality. So how would I write this answer using interval notation? Parentheses. Why is it a parentheses instead of a bracket? It's not equal to. We only use the brackets when we were equal to something. So if we had a closed circle, we would use the brackets. If you have open circles, you use the parentheses, and this would be our final answer. On 3 and 4, we're asked to solve absolute value inequalities and then write our solution in interval notation. If you have an absolute value that's less than a number, that means that x would be in between the opposite of that number and the number. If you have an absolute value that's greater than a number, that means that you would have x is greater than that number, or x is less than the opposite of that number. So if you have a less than, you set up a compound inequality. If you have a greater than, you set up 2 inequalities. One looks like the problem without the absolute value bars. The other one, you flip the inequality and use the opposite sign. Well, just remember, if you multiply by a negative, you got to flip the inequality. So on this first one, we have the absolute value of x minus 15 is less than 17. The first thing I would want to do is set this up as a compound inequality. Negative 17 is less than x plus 15 is less than 17. Once again, the goal is to get the variable by itself in the middle. So what do I do to all 3 parts here? I subtract 15 from all 3 parts, and when I do that, I get negative 32 is less than x is less than 2. How would I write this answer using interval notation? I put parentheses on both of the endpoints for the numbers because I have a strict inequality. Your first step should always be to isolate the absolute values before you begin. So what's the first thing I need to do here? And then when I subtract 8 from both sides, I get the absolute value of 2x plus 7 is greater than negative 1. Are absolute values ever going to be bigger than a negative number? Absolute values are always bigger than negative numbers, so this is true no matter what you put in. If this would have been a less than, it would have been no solution, but because this is absolute values are greater than a negative number, absolute values are always positive. The solution here is going to be all real numbers. In interval notation, we say that it's the interval that goes from negative infinity to infinity. Just notice though, if I would have had this less than -1, that would have been no solution. That would have been the empty set. But for our problem, we have all real numbers as our answer. On number 5, we're asked to determine whether the relation defines y as a function of x, and we have a graph. When you're looking at a graph, how do you determine if that relation is a function? Does this graph pass the vertical line test? Yes, it does. So this is a function. On number 6, we have two parts to the questions. We're asked to do the following for the given function. First, find f of x plus h, and then find the difference quotient of f and simplify. Do y'all remember what the difference quotient is? It's f of x plus h minus f of x all over h. Part 1 is to find f of x plus h for this function. If this is my function, all this means is go to this side of the function and in place of x, plug in x plus h. So f of x says you take 4 times something and subtract 6. That something for this problem is x plus h. Then we simplify this. How do I simplify this? I distribute the 4, and when I do that, I get that this is equal to 4x plus 4h minus 6. Part 2 is to find the difference quotient of f and then simplify. Well, the difference quotient is f of x plus h minus f of x all over h. What can I drop in place of f of x plus h? What we said it was equal to, 4x plus 4h minus 6. Then I subtract off f of x, and f of x was, notice I put this in parentheses. I keep these terms in parentheses because I have to remember to distribute that negative. And when I do that, I get 4x plus 4h minus 6 minus 4x plus 6 all divided by h. Now I have like terms that I can cancel out, and that gives me 4h over h, and these h's will cancel out, so this is equal to, if you've done the algebra correct with the difference quotient, every term without an h in it should cancel out. Number 7, we're asked to determine the x and y intercepts for the given function. This is function notation, but I could also write y equals 7x plus 8. How do I find x-intercepts? To find your x-intercepts, we let y equal 0 and solve for x. How do we find y-intercepts? Which do you want to find first here? So to find our x-intercept, we're going to let y be 0 and solve for x. So that gives me 0 equals 7x plus 8. If I, let's say, subtract 7x from both sides, I get negative 7x equals 8. So x will be equal to what? Negative 8/7. So I have an x-intercept at the point negative 8/7, 0. Now let's find our y-intercept. So to find our y-intercept, we have y equals 7 times 0 plus 8. We replace x with 0, and that gives us y equals 8. So our y-intercept is going to be at the point 0 for x, 8 for y. So there's our x-intercept and our y-intercept. On number 8, we're asked to write the domain in interval notation. Here we have a fraction and a radical. What's the rule for the domain in fractions? The denominator cannot be equal to what? The denominator cannot be equal to 0. So I know that this denominator, the x, can't be equal to 6. What about for radicals? We can take the square root of any number except for what? A negative number. So if a number is going to be in the domain of this function, that means that 6 minus x has to be greater than 0. Now if that radical was not in the denominator of a fraction, I could say greater than or equal to 0, because we can take the square root of 0. But because it's in the denominator, I don't want to include the 0. So I could add x to both sides, and that gives me 6 is greater than x, but when I write this, I want my variable on the left, so I just flip the terms on the inequality, and I get x is less than 6. How would I write this answer in interval notation for the domain? Well, let me start by graphing it on a number line. If I had a number line here, I'd have a 6 right here. Would I use an open circle or a closed circle at the 6? Open circle, and then do I shade to the left or to the right? The inequality is pointing to the left. We shade to the left whenever our variable is on the left. So now how would I write this domain in interval notation? Parentheses, negative infinity, 6, parentheses. This would be the domain of this function. You just got to remember you can't divide by 0 and you can't take the square root of a negative number. Number 9. The instructions say to use the slope-intercept form to write an equation of the line that passes through the given points. Use function notation where y equals f of x. If I'm using slope-intercept form, the first thing I need to do is find the slope of this line, isn't it? Do you remember the formula for finding the slope? M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Dropping in the numbers then, what do we want to use for y2? So that's negative 4 minus 3 divided by negative 2 minus 1. And negative 4 minus 3 is negative 7. Negative 2 minus 1 is negative 3. And negative 7 divided by negative 3 is 7/3. So the slope of our line is 7/3. The slope-intercept form of the line is y equals mx plus b. I have a number that I can drop in for m. Do I know numbers for x and y? Sure, I've got a choice even for what numbers I want to use. I can use those two numbers then and solve for b. So I'm going to use the first point because those numbers are positive. So in place of y, I plug in 3 from the point equals, my slope was 7/3, and x here is 1, and then I just solve this for b. So that's 3 equals 7/3 plus b. How do I get the b by itself? I subtract 7/3 from both sides. 3 is 9/3 minus 7/3 is 2/3, so b is equal to 2/3. We're not done until we write our final answer using this information as f of x equals 7/3 x plus 2/3, and that would be your final answer. Alright, number 10, we want to write an equation of the line satisfying the given conditions. Write the answer in standard form with no fractional coefficients. Standard form looks like this: ax plus by equals c. That's standard form. So our line is going to pass through this point and is perpendicular to this line. What kind of slopes do perpendicular lines have? Perpendicular lines have negative reciprocal slopes. So the first thing I need to do is find the slope of this line. What's the easiest way of finding the slope of this line? Solve it for y. Then you've got y equals mx plus b, and you can see what your slope is. So I take my line 5x plus 4y equals 10, and I'm going to solve this for y. I subtract 5x from both sides, and that gives me 4y equals negative 5x plus 10. How do I get the y by itself? I'm going to divide all three parts here by 4, and that gives me y equals negative 5/4 x plus 5/2. So the slope of this line is negative 5/4. What's the slope of our perpendicular line? The slope of this line is negative 5/4. That means that the slope of the perpendicular line is going to be equal to positive 4/5. So I use this slope and this point to write an equation of the line. So in order to do that, I'm going to use or start with my slope-intercept form like I did over here. What am I going to plug in place of y? Negative 3, because that's the y from the point, equals m, which we said is 4/5, x was negative 3 plus b. So that gives me negative 3 equals negative 12/5 plus b. Now I can add 12/5 to both sides, and that gives me negative 3 is negative 15/5 plus 12/5 is negative 3/5. Using this now, I can rewrite my line as y equals 4/5, that was my slope, x minus 3/5. How do I get the fractions out of this equation? Because in standard form there's no fractions. Multiply both sides of the equation by 5. So I have 5 times y equals 5 times 4/5 x minus 3/5. And then I'm going to distribute that 5 across, and that gives me 5y equals 4x minus 3. In order to put this in standard form, I can subtract 5y and add 3 to both sides, and that gives me my final answer, 4x minus 5y equals 3. On number 11, I'm testing your remembrance of how to graph using transformations. I don't tell you what this function is, if it's a quadratic, cubic, or what. As a matter of fact, it's not. It would be a piecewise function. But what we see is we have a 2 outside of the parent function, an x plus 1, a plus 1 inside the parent function, and a plus 4 outside the parent function. So what does that 2 do? Let's start by summarizing the transformations. What does this 2 do right here? We have a vertical stretch, of 2, what does that plus 1 do? Does it move the graph up, down, left, or right? Moves it to the left 1, and then what does the plus 4 do? Up 4. The constant out in front of the parent function is a vertical stretch. Inside the parent function is a horizontal shift, and it moves opposite the sign. That's why we move to the left. And then the 4 here is a vertical shift up. So I take this y value right here at -2. If I multiplied that by 2, that would put me down here at -4. I take all the y values and multiply them by 2, so that puts me down here at -4. And then I move that to the left 1 and up 4, and that puts it right here. Then this point, if I multiplied that by 2, that puts me here at 2. 1 times 2 is 2. And then I move that point to the left 1 and up 4. This y value is at -2, and -2 times 2 is -4. So that puts it down here. And then I move to the left 1 and up 4. Puts this point right here. And then this point's at 1. It gets moved to 2. And then we move that to the left 1 and up 4 units as well. That gives me my 4 points. And then I just connect those points with straight lines. And that gives me my transformed function. Do you remember how the transformations work? You may want to go back and look at your notes on graphing functions using transformations. Right here in the notes from section 3.5, I did a summary of all of the transformations. So that was in section 3.5. You may need to go back and watch the 3.5 video even. Number 12 asks us to evaluate a function for the indicated value, and this is a piecewise function. On the left we have 3 different functions essentially over 3 different domains. So this would be the domain of that function, and it tells you when to use which of the 3 functions. So when x is less than or equal to 2, we have a constant function. If x is in between -2 and 4, including the 4, we have an absolute value function, and if x is greater than 4, we have another constant function. Here we're asked to find f of 4. If I label these equations 1, 2, and 3, and I ask you to find f of 4, which equation would I use? So f of 4, we would say, is equal to, replace x with 4, so it's the absolute value of 4 plus 1, and what is the absolute value of 4 plus 1? It's 5. On 13, I ask you to evaluate the function for the given value of x. So we're told f of x is -8x, g of x is -3x squared plus 6. I want you to find g minus f of x. Well, g minus f of x is equal to g of x minus f of x. So g of x, we were told, is -3x squared plus 6. And then we subtract f of x, and f of x is -8x. You just replace the name of the functions with what those functions do. So that's going to give us -3x squared plus 6, and then subtracting a negative is the same as adding. So we would say that this is equal to -3x squared plus 8x plus 6. On number 14, we're asked to identify the vertex and determine the minimum or the maximum value of the function. What type of function is this? Linear, quadratic, cubic? It's quadratic. And will it open up or will it open down? It opens up because the leading coefficient is positive. So is this going to have a maximum or a minimum value? It has a minimum value at the vertex. Do you remember that if we had this, our quadratic written in this form, the vertex is at the point hk. So looking at this function, we're going to have a vertex where? Not -2, it's positive because the negative is part of the formula. So our vertex is at the point 2, 6, and that is a minimum value because this quadratic opens up. This point right here is a minimum. So that means that our minimum value is 6. This is the vertex, the minimum value is 6. The minimum point is the vertex. The minimum value is the y value of the vertex. The x value of the vertex is where that minimum occurs. On number 15, we're asked to find the vertex, the axis of symmetry, and the intercepts for the graph of the function. If you have a quadratic function written in the form y equals ax squared plus bx plus c, so the vertex is at -b over 2a, f of -b over 2a. So for this problem, what would a be equal to? So a is equal to -1, b is equal to -4, and c is equal to 5. So to find the vertex, I would use -b over 2a, and that's equal to the opposite of negative 4 divided by 2 times negative 1. Well, the opposite of negative 4 is 4, and 4 divided by negative 2 is negative 2. So this is the x value of the vertex. To get the y value of the vertex, I just plug this value in place of x in this function, and I get y is equal to the opposite of negative 2 squared minus 4 times negative 2 plus 5. Negative 2 squared is 4, so the opposite of 4 would be negative 4 plus 8 plus 5. Combining like terms then will give me that y is equal to 9. My vertex then is equal to the point negative 2, 9. When you're graphing a parabola, and this one would open down by the way, the axis of symmetry is the vertical line passing through the vertex. The equation of that line is the x value of the vertex. So my axis of symmetry is the equation x equals negative 2. And then the other thing that I'm asked to find are my intercepts. How would I find my x-intercepts? I would set this equal to 0. So to find your x-intercept, let's solve 0 equals negative x squared minus 4x plus 5. Well, I like my leading coefficient to be positive, so I'm going to move everything over to the left, and that's going to give me x squared plus 4x minus 5 equals 0. Will this factor? Yes, it will, and I have x plus 5 times x minus 1. So x is equal to negative 5 and x is equal to 1. So I have x-intercepts at the point negative 5, 0 and 1, 0. Now I need to find my y-intercepts. To find your y-intercept, you let x be equal to 0 and solve for y. If I let x be equal to 0, what is y equal to? That one you can tell just by looking at it. So I've found my intercepts, my axis of symmetry, and the vertex for this quadratic equation. Number 16 says a fireworks mortar is launched straight upward from a pool deck platform 6 meters off the ground at an initial velocity of 53 meters per second. The height of the mortar can be modeled by this function right here, where h of t is the height in meters and t is time in seconds after launch. What is the maximum height? And then round to the nearest meter. What type of equation is this? It's a quadratic. The leading coefficient is negative, so when it launches it's going to look like this. The maximum is what point on that quadratic graph? The vertex. So basically this is another way of saying find the vertex. The x value of the vertex is going to be time measured in seconds. The y value is h, because t is in the position of x, and that's time in seconds, and y is in the position of h of t. How did we say we find the vertex of a quadratic equation when it's in this form? No, we don't set it equal to 0. We use negative b over 2a, f of negative b over 2a. A here is negative 4.9, b is 53, and c is 6. So to get the vertex, I start by finding negative b over 2a. So for this problem, that's going to be negative 53 divided by 2 times negative 4.9. And we get 5.4. That's the time that it takes for this mortar to reach its maximum height. What is the maximum height? Well, it's going to be h of 5.4. So we do negative 4.9 times 5.4 squared plus 53 times 5.4 plus 6. So we get 149 meters, and that's the maximum height. They said to round your answer to the nearest meter, and we got 149.316, and that rounded to the nearest meter is 149. 17. We're asked to find the zeros of the function and then state their multiplicities. I'm going to organize this into a table. One of my zeros is what? Negative 1 is a 0, and negative 9 is a 0. You missed one. 0 is a 0 as well. What's the multiplicity of this 0? Negative 1. 6. It's the power that that's raised to. What's the multiplicity of negative 9? 5. And what's the multiplicity of 0? 4. You weren't asked this for this problem, but we did go over it, and it is fair game on the final. Will the graph cross or touch at negative 1? What about at negative 9 and at 0? If your multiplicity is even, the graph will touch the x-axis at that point, but if your multiplicity is odd on your 0, your graph will actually cross. The higher the power, the flatter the graph becomes at that x-intercept. On number 18, we're asked to sketch the graph of the function. So let's start by plotting our zeros. I have a 0 where? at -1, so there's a 0. Is the graph going to cross or touch there? It's going to cross. And I have a 0 at +2. Now the other points that you want to find are your x and y intercepts. Those are easy to get. Well, those are the x-intercepts. The y-intercepts, how would I find the y-intercept here? Plug in a 0 for x and solve for y. So when I plug in a 0 for x here, I get 1 to the third is 1, and -2 squared is 4. 4 times 1 is 4, and 4 times a half is 2. So I've got 3 points on this graph already. What is the degree of this polynomial? Is the leading coefficient positive or negative? That's positive. So I have an odd degree and a positive leading coefficient. What will be the endpoint behavior? We start at the bottom, so we're going down here, and we said we crossed here, so that's good. And we go up through this point, and then we come down and touch and go back again, and that's our odd degree. This is close enough. It's not perfect by any means, but this would be close enough because it satisfied all of the conditions that I would be looking for. It's got your intercepts, it's got, oh, by the way, this was a cubic, so this graph would kind of flatten out a little at this point. It would actually look a little bit more like this. There you go. Because it needs to flatten out a little, it doesn't just go straight through. So if you graph this on your graphing calculator, you would get something that looks similar to this. You could be more precise by making a t-chart and plotting points, but where's the fun in that? But do you see the thought process we go through? Find your x-intercepts, find your y-intercepts, determine if the graph crosses or touches at those x-intercepts, and then look at the degree so you can determine the endpoint behavior. I knew because the degree was odd and the leading coefficient was positive, my endpoints were going to have this behavior. They were going to move in opposite directions, start at the bottom and work your way up. Number 19. We're asked to factor this function given that 2 is a 0. How does knowing that 2 is a 0 help me? This is a third degree polynomial. If that's a 0, then what must be a factor? A factor is like x plus a number, x minus a number. X minus 2 is a factor, so that means that if I take this polynomial and I divide it by x minus 2, I'm going to get a quadratic. But if 2 is a 0, I could use synthetic division to work this cubic function down to a quadratic. So that's 4 minus 29 minus 7 and 98. Do y'all remember doing synthetic division? So I drop the 4 down. 2 times 4 is 8, and that's going to give me a -21. 2 times -21 is -42. And -42 plus 7 is -49. And -49 times 2 is -98, and -98 plus 98 is 0. So that means that my function can be written as x minus 2 times 4x squared minus 21x minus 49. Can I factor this further? Sure I can. It's a quadratic. It'll factor further. How do you factor the quadratic? Well, we look for factors of 4 times -49 that will subtract to give us -21. So let's try 4x and x, 7 and 7, because 7 times 4 is 28, and I could make that negative. 28 minus 7, -28 plus 7 gives me a -21 in the middle, and 7 times -7 is -49. This would be our final answer. The fundamental theorem of algebra says that every polynomial function can be factored into a product of linear or quadratic factors. The quadratics will be prime. On number 20, we're asked to list all possible rational zeros. Do y'all remember that was the p over q, where p is the constant over the leading coefficient? So when I list all possible factors here, I'm going to look at factors of 22 over factors of 4. So that's going to be plus or minus 1, plus or minus 1/2, plus or minus 1/4. And then another factor of 22 is 2, so that would be 2 over 1. 2 over 2 I've already got is 1. 2 over 4 is a half. I've got that. Another factor of 22, I've got 1, I've got 2, and I've got 11. 11 over 1 is 11, 11 over 2, and then 11 over 4. And this is every possible rational zero. kind of working backwards. I'm going to show you how I did it now. I took factors of 22, 1, 2, 11, and 22. Oops, I missed one, didn't I? 22 over 1 is 22, so I need to add that in. Take all of the factors of the constant term and I put them over all possible factors of the leading coefficient. The factors of 4 are 1, 2, and 4. So I did 1 over 1, 1 over 2, 1 over 4. That's these numbers right here. 2 over 1, 2 over 2 is 1. I've already got that. 2 over 4 is a half. I've already got that. And then I take the factors of 11 over 1, 2, and 4. Well, there's 11 over 1, 11 over 2, 11 over 4. And then I do 22 over 1 is 22. 22 over 2 is 11. I've already got that. And 22 over 4 is 11 halves. I've already got that. So that's how you would find all possible rational zeros. Number 21, a polynomial f of x and one of its zeros are given. Factor f of x as a product of linear factors. They're giving us one of the zeros that happens to be an imaginary zero. What do we know about imaginary zeros? If 1 plus 5i is a zero, what is another zero? Imaginary zeros come in conjugate pairs. 1 plus 5i is a zero. 1 minus 5i is also a zero, and that means that I can write these as factors. If I multiply this out, then that gives me a quadratic that I could use to figure out what this factors into. I'm going to go ahead and distribute that negative, and that gives me x minus 1 minus 5i times x minus 1 plus 5i. And then I need to distribute. I'm going to distribute the x across, distribute the 1 across, and then I distribute that negative 5i across. And when I multiply that out, that's going to give me x squared minus x plus 5xi, and then minus x plus 1 minus 5i minus 5xi plus 5i, and then minus 25i squared. So we end up with x squared, and then I have like terms. Minus x gives me a minus 2x. The plus 5xi and the minus 5xi cancel each other out. The plus 5i and the minus 5i cancel each other out. And what is I squared equal to? It's negative 1, and negative 1 times 25 is a positive 25, and that I can then combine with this 1 right here, and that means that x squared minus 2x plus 26 divides evenly into this cubic function. 4x cubed minus 13x squared plus 114x minus 130 divided by x squared minus 2x plus 26, which is a prime quadratic factor. So that cubic divided by this quadratic using long division is going to give us 4x, and then we multiply. 4x times x squared gives us a 4x cubed. 4x times negative 2x gives us a negative 8x squared, and 4x times 26 gives us 104x. And then I need to subtract, so that means I'm going to change my signs and add. So these terms are going to zero out, and negative 13x squared plus 8x squared is negative 5x squared, and 114x minus 104x is 10x minus 130. When I divide negative 5x squared by x squared, I get minus 5, and then I distribute. Minus 5 times x squared is a negative 5x squared. Minus 5 times negative 2x is a positive 10x, and minus 5 times 26 is 130, a negative 130, and then I change my signs and add, and I get the remainder is 0. So that means that I could write f of x as my factors 4x minus 5 times x minus 1 minus 5i times x minus 1 plus 5i, and I've factored that completely. On number 22, we're asked to identify the asymptotes. So do we have a vertical asymptote? Yes, we do. How do we find our vertical asymptotes? So we have a vertical asymptote at x equals negative 2, because that's where the denominator is equal to 0. Do I have a horizontal asymptote here? The degree of the numerator is bigger than the degree of the denominator by 1. If the degree of the numerator were less than the degree of the denominator, I would have a horizontal asymptote at the x-axis. If the degree of the numerator is equal to the degree of the denominator, my horizontal asymptote would be the line leading coefficient over leading coefficient. But when it's greater than, I don't have a horizontal asymptote, I have a slant asymptote. How you find your slant asymptote is you take the numerator and you divide it by the denominator. I'm going to use synthetic division to do my division, so my coefficients are -2, 2, and -3. So I drop down the -2. -2 times -2 is 4. 2 plus 4 is 6. -2 times 6 is -12, and -12 minus 3 is -15. This part is my remainder. This is -2x plus 6, and this is the equation of my slant asymptote. It's a linear equation. So this rational function has a vertical asymptote at x equals -2 and a slant asymptote along the line y equals -2x plus 6.